Hi everybody, today we're going to go over graphing, families of graphs, all the transformations, some things from Algebra 2, maybe some things that are newer. If you don't have the notes, scrap a piece of paper. I'm going to just make a complete map of every transformation. So I'm going to start with a square function. So I'm just going to start with y equals x squared. So I'm going to just make this kind of explode out really quite a bit. So it's that's why there's so much space here. So we're going to have our function. And we're going to have a bunch of stuff that happens in front of the function. As you know, we can have parentheses. That's where the quantity squared comes in. The variable, of course, is inside here. I left this box here because we're going to have something going on right here. Now, probably the transformation that everyone is most familiar with is the stuff that occurs outside the parentheses, which is up and down. So I'm getting ready to write up and up. So we have plus and minus. Positive moves the graph up. Negative moves the graph down, however many units that number would be. The next easiest one is inside the parentheses. But inside the parentheses is always sort of backwards or inverse or reciprocal to what you might think. So the inverse obviously would be, in this case, opposite. So instead of thinking as positive is going to the right, positive is going to go to the left. And negative, of course, would go to the right. Now I'm going to leave my box blank right there, but I'm going to do another box out here. And of course, we have a sign. So something that you did in Algebra 2 was talk about vertical stretch and vertical shrink. Our book doesn't really use stretch and shrink, but it's fine if you decide that that's the language you'd like to use. I'm going to refer to this value as C. So if that number is greater than 1, this is going to be a vertical expand, or stretch, if you'd rather. If this number is between 0 and 1, then we're going to have a vertical shrink, or compress. And it's really okay if you sometimes say shrink, sometimes say compress, sometimes stretch. It doesn't really matter. Stretch and expand are interchangeable. Shrink and compress are interchangeable. And then, of course, we don't care about the fact that this only goes to 0 because anything negative is controlled by that sign out there, which is a reflection over the x-axis. So if it points up, it now will point down. Now let's head inside the parentheses. This is a horizontal stretch or shrink. And because it's inside the parentheses, you always have to do kind of weird stuff to it. So in this case, we're going to find the reciprocal, not the opposite. We're going to flip it. And if you flip it, then it follows the same rules as the ones we just went over. So after you flip it, so flip it first. If that number, the flip number is bigger than 1, then it's going to be a horizontal expand. And if you flip it and it becomes a fraction, again, now we don't care about positive, negative. So that means it falls between 0 and 1. This is now going to be a horizontal compression. And the last thing that we have that maybe you did not have before is the negative sign inside the parentheses, which looks a little bit weird, but it can happen. And this is a reflect over the y-axis, which sometimes the reflection over the y-axis is not possible to see on the calculator. So now let's just practice a few of these. We're also going to practice some graphing without the calculator. So when you're asked to describe the transformations, it doesn't really matter what order you do them in. So anything that's on the outside is up or down. You can just say up to. You do not need to say translated up to units. So you can just give me the direction and the number. For the next part, we don't really have parentheses, but the radical sign counts as sort of housing in the left and right movements. So this would be right 4. Now for part C, we have 3, because we have 3 things besides the parent. We have the negative, the 3, and the 1. So you don't describe the radical, and you don't describe the letter X or Y. You describe all the other things. I'm just going to go in order from left to right. This is not the order you would graph it in, though. We're going to reflect over the x-axis. Please say x-axis. Please say reflect. You don't have to say over if you don't want to, but I need reflect, I need x-axis. Don't just say x. Then we're going to have left 3 and, of course, up 1. Now, this is the rational function, as you know from studying your parent functions. It has 2 asymptotes. It's hard to graph. It's maybe something that you're not familiar with at all, which is okay. We will really focus on rational functions later in the school year. Right now, you just have to be able to recognize the transformations. You would not be asked to graph this without a calculator. X to the negative 1, that's a negative exponent. That's the same thing as 1 over x. So we do have the parent function, even though it's disguised as a negative exponent. Kind of a mean trick early in the year, but that's what we did. So this is really the same thing as 4 times 1 over x. And so now all we have to do is describe that 4. We are multiplying by 4. We're not dividing by 4. So this is a vertical expand, or stretch, if you'd rather, and say by how many. Part B is written a little bit better, as you can see the parts. So we have reflect over the x-axis, and of course, up 5. Now we're going to graph, and when you graph, you have to pay attention to the order, and the order really matters. So I know that everyone's really good at up and down. We save that for last. So the first thing you do is you go left or right, which is kind of falls in line good with kind of all math properties, and that you start with what's inside the parentheses first. Then we're going to do anything that involves multiplying, whether that's multiplying by a fraction, a whole number, doesn't matter, whether it's inside, outside, just vertical, horizontal, doesn't matter. We'll do all the multiplying next. Then you reflect, which is clearly taking care of all the negatives. So when we multiply, you don't multiply by a negative, you just multiply by the value. And then the very last thing we're going to do is we're going to move this thing up or down. There's a couple ways you can do this. You can do it straight to the graph. You can just count the squares, do it right to the graph if you'd like. I'm going to do that for this one, and then I'll do the second one a different way. So this is your parent function for the absolute value, 0, 0, 1, 1, 2, 2. You know all these, negative 1, negative 2, 2. So here is the parent function. I just put the parent function on there so we could actually have something to sort of, actually physically move. So we have left 3, and we also have up 1. I don't know why it's doing that. So if we count this thing and we go left 3, so I'm going to start with this one. I'm going to go left 3, 1, 2, 3, up 1. Then I'm going to do that with this point, left 3, up 1. And then I'm going to also do 1 to the other side of the vertex, left 3, up 1. And there is the answer for f of x. Now you do not need to put the parent graph on your picture. I just did to show you how to physically do that if you'd like to do it that way. So it's a pretty easy way to do it. Make sure you follow the correct order though. That particular problem, the order would not have mattered. In number 4, the order is really going to matter. So I'm going to first come up with what am I supposed to be doing. First thing would be left 1. Then I'd have a vertical stretch by 2, and then I'd go over the x-axis. So that's the order. I don't have any up or down. So I'm going to start with the parent function. And as you know, parent function is 0, 0, 1, 1, 4, 2. So if you want to graph that, we can graph that. It might be kind of interesting to see if it actually turns out correct, which I would suggest that you do. So I'm going to graph the parent function, then I'll show you all these things and see if it really does happen without doing the graph. So left and right are obviously controlled by x. So we would subtract 1 from all of the x values. I'm doing this with the numbers. Vertical stretch, well, to stretch something vertically, we would stretch it up and down. That's controlled by y. So we'd have to multiply all the y values by 2. I'm going to rewrite my table now because I just have a bunch of numbers there. So let me move this over. So now you have negative 1, 0, 0, 2, and 3, 4. Now, when you reflect over an axis, you change the signs on the other number. So since we're reflecting over the x-axis, you change the signs on the y. I'm not going to make it negative 0. You can if you want to, but that's really not a thing. So now I'm going to graph this. So I have -1, 0, 0, -2, and 3, -4. So here's the final answer. And you can see it makes sense. We do have a vertical stretch. It did point down, like reflecting over the x-axis. It does move 1. So that's another way you can do it. You can also combine the two methods and do some on the graph and then some with the table. Just do whatever makes sense to you. If you need help with that, of course, I will help you with that. Now we're going to kind of switch gears here and talk about even and odd. So they asked for you to draw these two graphs on your calculator. This one is, of course, not a parent function, but it is a quartic. Now this one you should know, of course, we just did it. And so there's our graphs. And I wanted you to just take a look at two graphs. The type of symmetry is y-axis, which is basically like a fold. If you can fold it on the y-axis, that's what line symmetry means. It's if you fold it on the y-axis, both sides would match up perfectly. This is different than these graphs. So again, here we have a parent graph, which you should be able to graph perfectly without the calculator. This graph is crazy, sort of intentionally. I don't know if my picture is going to do it justice here. So it looks kind of wiggly like that. These graphs are odd. Now, it's hard to see on the video, and if you take your calculator, if you graph any one of these, and if you physically flip your calculator upside down, you'll see that the graph looks the same. So this means it has symmetry with respect to the origin, which is the same thing as rotating it 180 degrees. Now, you got to be careful with this. If you're just going to be the person that looks at the powers and go, oh, odd power, odd power, odd power, so it's odd, you're going to be in trouble with some certain things, like that one. Because that's technically x to the first, which is an odd power, but this is an even function. So you want to be careful with how you evaluate it. Probably the best way to evaluate it is to put it back in and do it algebraically. So it says for 7b, to evaluate f of -x, or plug in a -x in for all the x's. When you substitute, you should always use parentheses. So we're going to have -x to the fifth, like that, minus 3 times -x to the third this way. Oops, sorry, this is supposed to be on the outside. And then, of course, plus 4 times -x. So an odd power, a negative number makes it negative. So this is a negative times a negative, so we'll have positive 3x to the third and a negative 4x. If we do the same thing for 5a, which was this, 2, and then we'd have x to the fourth like that, and then we'd have x squared, so it'd be -x squared. When you do this, this is an even power, so this is going to come out positive, and this one's also going to come out positive. So if we kind of put all this together, I know it's kind of everywhere, but if we kind of try to put this together a little bit, even function has symmetry with the y-axis, or fold in half, and when you plug in a -x, you get the original function. It does not change sign. An odd function has symmetry with respect to the origin, which is a rotational symmetry, and when you plug in the negative, you get the opposite of the original function. So maybe a little bit more on even and odd than you needed, but I want to make sure we go over details. The graphing we will be doing for some more days, so hang tight on that. I just wanted to give you a good sort of overview. Make sure you do the homework on page 84.